Denise, it is 10:30. Would you like to get started?
Yep, Joanna, go ahead. We have a lot to cover.
Great. We do. Thank you to everyone for joining us today. Again, this is Joanna Riegel from KMJ Consulting. I'd like to welcome you on behalf of the I-95 Corridor Coalition to their webinar, Private Sector OD Data TSMO Applications. Just a few housekeeping items. The call-in number is on the screen. Participants will be in listen-only mode throughout the webinar. Please press *0 to speak to an operator regarding questions for audio. If you have any other questions about the web or the audio application, you can reach Wayne Gibson. His number is 609-970-2584. This webinar is being recorded, and presentations will be posted to the Coalition's website following the webinar. All participants will receive a link to the presentations after they have been posted. As I mentioned, since all the attendees are in listen-only mode, we will be using the chat box for questions. Just simply type your question in, and the speakers will respond to you either at the end of their presentation or at the end of the webinar. I'd, at this point, like to turn it over to Denise Marco, the TSMO Director from the I-95 Corridor Coalition, and she will be your host for today.
Thanks, Joanna. Good morning, and thank you to everybody who's on the call today. We have some great speakers lined up, and let me start quickly with starting with the agenda. Joanna, if you would switch to the agenda, please. We have a lot to cover. So, after the introductions, we're going to hear from Joe Guthridge at HERE, talking about the traffic analytics trip data that they have, followed by an overview of INRIX's trajectory data offerings and capabilities. Then, following Rick Schuman at INRIX, we will be talking to Dr. Sepehr Ghader from the University of Maryland Transportation Institute. He's going to be looking at developing national multimodal origin destination products. That'll be followed by Dr. Franz from the CATT Lab. He's going to talk about web-based analytics for trajectory and OD data. And finally, we will have Michael Pack from the CATT Lab looking at signal timing analysis using trajectory data and analytics. And that I will finally wrap it up. Wow, that was a mouthful. Okay, next slide, please. So this is one of our national audiences for one of our Corridor Coalition webinars. Currently, we have, looks like 254 folks that are registered from about 28 states. And so down below, I think you can see the different types of agencies that are attending. We hope that you will, if you have questions, provide some questions in the chat box, and we can have a lively discussion. Thanks, Joanna. So, just a brief a blurb on the coalition. We really are from Maine to Florida. We are 16 states plus the District of Columbia, and we offer a lot of opportunities.
This meeting is now being recorded.
In terms of these types of webinars, events, and peer exchanges, as you can see from the metrics and the fact that these metrics are probably about 10 years old. We were considered back in 2008 the second largest economy in the world. And so I know that we're growing, and as we update that metric, I'm sure that's going to only increase. Next, Joanna. So a little bit of background for this webinar. In 2008, the coalition brought you the Vehicle Probe project. It was probe-based speed data. We introduced it. It was groundbreaking, transformative, as you can read, and it's enabling agencies to do some good work. 10 years later, today, we are now looking at two new types of data sets that are going to hit the streets shortly. So the coalition is here to inform the members about them. That's some of the core of the meeting today. Lastly, next, Joanna. Today's webinar, we're going to introduce two new data sets, origin destination data, OD data. We're going to talk about trajectory data, and basically AKA trips. We're going to explore a national OD study, and then we're going to discuss some emerging TSMO and planning applications leveraging the OD and the trajectory data set. So with that being said, let's move on to our speakers. Next, Joanna. righty. I am going to, for the sake of expediency, I'm going to introduce the speakers at one time, and then we will move from presentation to presentation. So first up, we have Joe Guthridge. Joe's the Senior Product Manager at HERE Technologies. He's based at the HERE offices in downtown Chicago, and his product responsibilities here, they focus on traffic data, both analytical and real-time products. He works across several markets. So he works with the public sector, the automotive, transport, and logistics industries, and he's served in this capacity at HERE for about 6 years. Prior to that, he worked at in the mobile email market at Nokia and a development manager for productivity software at Lotus. He graduated from Rice, and he's got degrees, both bachelor's and master's in electrical engineering. After Joe, we're going to hear from Rick Schuman. And Rick is INRIX's Vice President for Public Sector Strategy and Partnering. He joined INRIX in 2006. He was the project manager for the INRIX's initial, the VPP Phase 1, the Corridor Coalition's project, and he's been with this project from its inception. He also serves as the project manager for INRIX's NPM RDS initiative with Federal Highway, and that initiative, it serves as the default speed archive for federal congestion reporting requirements. He's been deeply involved in ITS and transportation operations for over 25 years, and he was an original staff member, which I did not know, of ITS America. After Rick, we're going to hear from Dr. Sepehr Ghader. He is a research scientist at the Maryland Transportation Institute. He has a master's and a science and PhD in civil engineering, also a master's in statistics from the University of Maryland. So he's going to talk a little bit about developing our national multimodal origin destination products. He's been a project manager for several projects funded by state and federal agencies, and his focus is on travel behavior, big data, and travel reliability. The fourth presenter is going to be Dr. Mark Franz. He's from the CATT Lab. He has a BA in physics, a BS in astronomy from the University of Florida. His MSCE, or his Master's in Civil Engineering, is from West Virginia University, and his PhD is in Civil Engineering from the University of Maryland. His emphasis is transportation engineering. He is the lead transportation analyst at the CATT Lab, and he's developing and improving online transportation tools and visualizations for the public and private sectors. And then last, but certainly not least, is Dr. Michael Pack. He's the director of the CATT Lab from the University of Maryland. He works to make transportation data more easily accessible. He's known probably as the father of the RITIS, if I can call it that, and he worked at the University of Virginia and Oak Ridge National Laboratory prior to coming to UMD. That was a mouthful as well. So with that being said, let me turn it over to Joe. Joe, can you hear me? And we can start with Joe.
Sounds great. Yep. Can you hear me?
I can.
Great. Thank you very much. Yeah, this is Joe Guthridge. I'm with HERE. I would like to talk to you for the next 10 or 15 minutes about trip data, which is the product that HERE has in traffic analytics. It specifically talks about origin destination data. You want to do the next slide, please, Jonna? Good. Yeah, that's my cover slide. So let's go one more. The trip data is a part of the traffic analytics suite of products at HERE, and these products are defined to be analytical data products based on traffic data, and they're essentially designed to be used to provide data for your favorite analysis or modeling tools. The speed data product predictably talks about speeds on roads, and it's a historical record of speed observations on roads for the past 5 years. The trip data product in the family is the one we'll talk about today, and it talks about trips that people have taken, and today it offers also 5 years of history. We update it quarterly, and it's available in several countries, including the United States. And it comes in a couple of different formats, and I'll talk a little bit more about those formats in a minute. But for the moment, on the next slide, I would simply like to make the point that both of these products are based on the GPS probe data, also known as floating car data, that HERE accumulates or acquires from different sources around the world. We've made a very large investment, an ongoing investment in sourcing these probes. We feel like the probe data is a very reliable source of data for understanding traffic behavior. We've been doing this for over 12 years now. And today we have 110 different probe providers around the world. The latest set of probe data that seems to be extremely valuable in terms of quality is data that comes directly from connected cars, and this is included in our speed data and trip data data sets. Connected cars are cars that are designed by the auto manufacturer to take very accurate GPS readings and send them regularly with very low latency to us. They're good because they don't depend on navigation system implementation in general, and also because they're sort of wired into cars. They have really good antennas, and they do a really good job with their GPS, including in things like in tunnels where inertial seat of pants navigation is good to bridge reception gaps from satellites. So here bases all of these products on a large fleet of probe data. Next slide, please. That brings me to talking about the trip data product. Out of this collection of probe data that here has access to every minute of every day, we use this data for our real-time products, and then we archive it. And part of that archiving process is understanding trips people take. Now, the probe data is supplied to us anonymously, but it has some vehicle IDs, and so those we use to stitch these GPS observations together into traces that show where a device has been, and not coincidentally the speeds and directions that were observed at those times. So here applies heuristics to these traces to recognize the trips that vehicles or people would have taken based on those observations. So you can think about the possibility of a truck, or maybe talk about a taxi cab that's on all day long. It takes a lot of trips, although it may provide just one trace. So here doesn't get any direct signals from its providers about when sort of notional trips begin or end on the road. So we apply heuristics to the data, to the traces, to recognize the trips that were taken. And there are some rules that go along with those heuristics. Anyway, that winds up being represented internally to here as a list of trips that we've observed with their origin and destination and the road segments that they traversed. The trip data product then is what we offer to customers, and it represents queries into that database. Here doesn't sell direct access to that database for privacy reasons as well as some business model reasons. So the trip data product essentially consists of the fulfillment of a fulfillment process where a customer will fill out a form that says what time range they were interested in, what area they were interested in, some aggregation parameters, and then a description of the area that they're interested in. And what we return is an origin destination matrix giving medium and long-term statistical data. So the data is available back 5 years and as recently as a few months ago. It's not updated in real time. So this origin destination matrix includes counts of observed trips between origin destinations and also the, well, I said counts and durations, yeah. There's an additional option to identify trips across specific road segments that I'll talk about in a minute. But in general, you think of the product as an origin and destination matrix. And so the advantages of that are, I think, at least the first advantage should be pretty clear to everyone on the call. Using this data that we've been already collecting for 5 years is an immediate solution to the problem of sampling travel demand. Much more cost-effective than sending out travel diaries or setting up roadblocks to acquire that data. In addition, the product is set up so that an individual customer can provide us with the zone structure that they're interested in. Many public sector customers already have traffic analysis zones defined for their jurisdictions. And we simply take the shapefile that represents those TAZs and relate our trips to them and provide the origin destination matrix coded to your specific TAZs. You can provide us with census blocks or postal codes or any other sort of zone division of your area of interest, and we can tailor our results to that as well. Because our probe source fleet is composed of both trucks and passenger vehicles, and we've coded them that way, we can provide you a matrix that's strictly trucks, strictly passenger vehicles, or a combination of the two at your choice. And granularity is down to 1 hour of an individual day, although we suggest that you get a more aggregated form of data that looks at things maybe by time of day, but aggregated across several months. So that's an overview of the product. Let's talk a little bit more about the formats in which it's available. Actually, let's talk about how you might use that, and if we could skip to the next slide. We're fortunate enough to have a really sharp advertising agency in the Netherlands do a great promotional video. It's a little bit long to share with you right now, although the link is at the bottom there, but I'll just share a couple of screenshots from it. And in this case, trip data was used to analyze commute patterns over a few months at the morning rush hour among the 5 cities that comprise the Randstad, a highly developed area in the Netherlands. And what the study found was that Utrecht, the city, had the most inbound trips at the morning commute hour of any, and its primary source was Amsterdam among the 5 cities that were considered. So on the next slide, what we did was then we drilled into Amsterdam, the biggest city, and looked at commute patterns across the morning commute within the city itself. And in this case, there were much smaller zones defined for our analysis. What it found was that the most trips at rush hour, anyway, we can say, were destined to that spot in the bottom right of the screen, which turns out to be a former warehouse district in Amsterdam, which has recently been redeveloped into a lot of office space. So it makes sense that the data showed that this sort of commute pattern in the mornings. So that's a couple of kinds of analysis that you could do with trip data at a very high level. There are a lot of others. As I said, trip data and speed data both are meant to be data sources for a wide variety of analyses. Next slide, please. I'll talk about two primary options in the trip data product. I've talked at this point mostly about the grid format on the left, a standard origin destination matrix. So basically it's a lot of pairs of from this origin to this destination zone. We saw this many trips, and the average duration was this. This form, it could be used for traffic modeling or in any way to understand the demand of travel on the road network. The other format we call the TMC format, and it's essentially a single gate format. So you can specify the TMC format to be produced, and what this does is to further divide the trips down by the road segments they crossed. So you can say for a given road segment, what were all the trips that crossed it, what were its origins, and what were its destinations. So it's essentially a way to derive multiple origin destination matrices for one for each road segment in the jurisdiction or in the area covered by the sample. So this allows you to understand more in detail how exactly a given road segment is used, what its transportation purposes have been over the sample period. Where do people come from, and where do people go to when they use this road segment? Yeah. So next slide, please. As I said before, probe data that we use is anonymized. Still, when you string a bunch of anonymized observations together, you start potentially infringing anyway, on personal privacy. And the reason for that is if you have a record that shows a single trip from a zone where there happens to be only one house, and in the pictures that I've chosen here, it's obvious that the one house is the White House. Then you could likely identify that trip with a single person. And this violates our concepts of privacy and also related concepts like the GDPR in the EU. So trip data has to take extra measures to protect the privacy of its sources and its contributors. And the way we do that is when we process an individual query against our trip database, we filter out any resulting records that would depict fewer than 7 trips. So there's no way to get a 1 or 2 trip record out of the system, and therefore privacy is fully protected. What this means is that we have to balance for any customer engagement the notion of data sufficiency and data granularity. You could ask us for trip data for each hour of each specific day over the past few months, and we could give that to you, but the chances are we wouldn't give you much of it because the sample rate would be relatively low in that high granularity. So what we typically do in engagements is that we work with a customer to say, okay, you probably want to look at sort of, maybe you want to look at weekdays versus weekends, but you're not so concerned with traffic every hour, and gives us the opportunity to aggregate at a higher level and provide a richer set of data to support your analysis. Next slide, please. Yeah, so I included this slide. It contains the number of trips that we've added to our database over the past few years per country. The next to the bottom line shows the USA. We're doing right around 2 billion trips a year across the USA. 2017 numbers were down a little bit because of our fleet was restructured a little bit. The 2018 number was first half, so that's running about the same level. Next slide. So the trip data product is part of the core bundle if you choose here as your data provider as a 995 coalition member. You can see here that that core bundle includes our real-time traffic service and then both our speed data and trip data products and also our APIs. So access to a few queries of trip data is part of the core bundle with the I-95 Corridor Coalition. Next slide, please. Let's see. So I'll pause and say if you have a few questions right now.
There is a question for you.
Joe, there's one question in the box talking about from Haroon. For trip data, he's asking what's the market penetration rate?
Okay, the market penetration rate is not something we actually can comment much on, and the reason for that is that our sample fleet varies across the U.S. and across countries. So the penetration rate is a bit variable, and so it's not something we can speak concretely about.
Okay.
Trip, I see the next question from Haroon. Trip purposes, we do not have any information about purposes.
Joe, what I'll do is probably what we'll do is in the just for the sake of expediency, let the questions start to roll in the chat box, and if you can answer them, and then we'll go on to Rick's presentation next, and I think we can kind of do 2 things at once here, if that works.
Sounds great. Absolutely. Thanks. Thanks for the time.
You're welcome. Watch the box, and Joanna, next presentation is Rick Schuman, I believe.
Sound check?
Sounds good, Rick. Are you gonna move your slides?
Perfect. I will. Yes. Okay.
Thanks.
Good morning, everybody. And so what I'll do here is I have a set of slides. As usual, I have more slides than time. But the point here is they'll be on the record, and you'll be able to go back and look at them. And what I'm presenting today is a component of our overall origin destination product suite. We have many of the same tools that Joe mentioned. But we also work with several partners that, for instance, Streetlight Data, that take this, what I'm going to describe here, and create robust tool sets on top of it to go further and deeper. And what I'm going to focus on today is what we call our trip data, trip records data, trip reports, trajectories. There's a lot of different names for it, but fundamentally what it is it's the actual underlying trips. You know, Joe mentioned that They do not share the trips. We do. We do in certain countries where it's allowed. We do, and we manage the privacy parts. I'll explain in a couple of ways. One is by obfuscating the origins and destinations a fair bit, and then managing the rest by license, how they can be used and so forth. But our goal is to enable agencies and those that work for agencies to be able to see rich data, particularly as it travels along the network. Privacy issues about where you start and end are clearly valid, but vehicles traveling along an interstate or a corridor, the notion of precise location and time of vehicles moving through that, how they move, is something we feel is very useful to the industry and has been proven out by customer interest. I won't spend much time on the overview of the trips. Just think about this as a massive drive test database. If you're doing your own floating car runs, anybody that's done that, you know what we're talking about. Very similar to what Joe said, the data that we use for real-time purposes. Also now it's pieced back together into individual trips. The category types of providers, sources, you'll see some things as we go by. It allows you to separate out freight trips, for instance, and everything is time-stamped, date and time-stamped as well. The use cases here, as Denise mentioned, much like the early days of probe data, we start with a list of use cases that we think would work if you're getting segment speed and travel time. Those got proven out. Some are more useful than others. Others got added as customers and agencies started leveraging the data. The same thing is happening with the trip data. This is not an exhaustive list. It's representative, and I think folks on the call, you may have ideas for what you can do if you had a massive drive test database that was updated essentially daily. What I'm going to focus on here is what we call our trips report. This is a product that I'll explain that's available for licensing across the country and a handful of other countries. And in particular, we've got an arrangement with the Coalition and the Vehicle Probe project I'll explain. This is a standalone product and data set. And what it basically does is it allows an agency essentially say, I want data and this in a particular region, in a particular time frame, and every trip that starts, ends, or goes through that region is provided as a data set under license. I have an example here that I pulled for a corridor, the corridor in Miami-Dade County. Pick the day, trip, sample, and just give you a sense of the context. 23,000 a particular day, September 25th, went through that polygon of the I-95 corridor down there in Miami-Dade County. There's a lot of files. We can explain more in depth and direct engagement, but fundamentally there are two key files. There's a third file that lists kind of the providers at a anonymous level, that the type of provider that, this is a connected car, and versus this provider might be a connected fleet, versus this provider might be a mobile device source, for example. But the two key files are the trip data and the waypoint data. And so the trip data file is a file that identifies every trip. Every row here is a trip that in this file talks about the start and the end time and location. And we obfuscate the location a bit. It still fits into analysis zones, but the idea is it's not down to the highest resolution data that we get. And there's a whole bunch of things around metadata around the trip itself as well. And so the second file that comes along with that is a much larger file, and that's the waypoint file. So for every trip, we identify the actual GPS readings that are sent to us from the provider or from the device or vehicle directly that we've pieced together that through that trip. And so it's an indication here, an example of what's provided. It's tied to a trip, the waypoint sequence, the timestamp, the latitude, longitude, as precise as we get it ourselves, and the segment ID in cases where it's on our road network. We provide you the actual segment references for the network, for example. As I mentioned, the product, INRIX Trips Report, is available for agencies and consultants and academia for use across the U.S. and several other countries. And in particular, we've added it earlier this year as what's called an ancillary product to the Coalition's Vehicle Probe project. And everything below that works the same way. It's just the pricing is the best pricing available for Coalition members and recognizing the overall marketplace. Those of you involved in the Coalition, you can talk with us directly, but ultimately you can license through the Vehicle Probe project contract. We have data back to January 2014, so we're approaching 5 years of data. And we add data daily. So yesterday is processing today, and it'll be available tomorrow in the data set. And so again, the concept is agencies license a region and a time period, and depending on the size of the region and the length of time, we have an agreed fee, and we have list price, and then we have an agreed fee with the Coalition. And importantly, in the Vehicle Probe world, the data use terms, those of you that are familiar, Vehicle Probe project, the same data use terms govern, which is a perpetual use license for the data once it's provided, provided you use it, as agreed. And one agency licenses and all agencies in the Coalition can use. What I've got here is several examples, kind of visuals of the underlying data, just to give a sense of the scale and the statistics of it all. I've taken several states against the Coalition webinar, so this is geared towards the East Coast. We can do the same thing in any other state, any other region. Basically, that box in the middle there, I drew around New Jersey, and I asked for a sample data for a day. This was in the spring of 2018, and you can see here in our data set over 500,000 trips started, ended, or went through what is nominally New Jersey there in my polygon. And you can see here the percentages of trips by vehicle type. In the case of New Jersey, about half of these trips were completed by passenger vehicles, and 35% long-haul fleets, 15%, local fleets, and 15% long-haul trucks. Again, the sources of our data to derive solid traffic data, we use a lot of local fleets and so forth. And so what we do with our data is we expose as much information as possible for you. And if you want to use analysis of truck data only, you want to use the entire fleet, you want to use passenger only, you can take the data and filter it out. The remainder of the charts I'm going to kind of go through fairly quickly, explain what each one of these images are. That the image in the lower right is actually an image of all the origins and destinations for that particular sample day. The light blue are origins, the reds are destinations. Obviously, the destinations overwrite the origins, and so in the scale of this thing, the dots completely cover New Jersey, and you can kind of see trips starting and ending various places in other neighboring states and a few states away in some cases. The lower left chart shows kind of the trip start and ends for that particular day by the hour. 0 is midnight, 23 is 11 p.m. at night. And you can see here the number of trips kind of represents a pattern that you would expect from overall trip data and the volume. And the upper chart is just an illustration of the average waypoint frequency. The data we get in from our providers can vary greatly. Some providers provide us data every second. And you can see here on the chart, some provide us, and you can see they kind of stratify around, data that isn't, incoming GPS data can be noisy. In this particular case, you can see it stratified around 1 second, 20 seconds, 30 seconds, kind of prime numbers, 40, 60, 80, 90, etc. And then some noise just from averages. But it gives you a sense of some data is high frequency, some data isn't quite as frequent. And again, every waypoint gets provided for the trips. This is just an illustration of if we went and sampled within that data. We have a tool that basically takes the data and shows it as if it were live, so that particular day. On the left, every dot there is actually a live probe moving through the network at noontime. And on the right is a blow-up of North Jersey, New York City metro area around 4 o'clock in the afternoon. And the different colors here, we combine the various metadata, the data we have from the providers incoming, and in this particular illustration here, we just identified different vehicle types as different colors. The blue are connected cars, the pink in this case are local fleets, the brown are long hauls, and greens are mobile apps, for example. Just gives a sense of the thing. So I'll kind of speed through this quickly here. In Maryland, same thing, took a day, 200,000 trips. You see similarly the mix kind of changes a little bit, passenger vehicle, local fleets, long haul trucks. But again, every day, 200,000 trips plus or minus are being added to the database. Virginia, 378,000 trips over a 24-hour period. The mix is, again, somewhat similar, a little more long haul as we move kind of to the mid-Atlantic. You've got the I-81 corridor, as we know. It's pretty heavy. Here's a view of kind of a live probe shot in and around Virginia. State of Georgia, we're up to over nearly 550,000 trips. Again, and we see a lot of truck data that Georgia's kind of one of those crossroads states with 75, 95, 20, et cetera, generate a lot of data. And again, these are all, you'll see these all in the PDF, the webinar. And there's an example of the probe data across the state live. One more illustration, taking some data in New York. And if we drew a box kind of in Midtown, we took a month's worth of data, and these are waypoints. First here, this is a picture for 1 day's worth of data. So these are all the waypoints for trips started, ended, or went through that particular area in Midtown. This is what a week's data looks like, and it starts all folding on top of itself. This is a week data zoomed in. This is a month's data, and you start seeing, the waypoints, obviously we give waypoints for the portions of the trips that are outside the region too. Anything that starts, ends, or goes through the region. You're going to see some uses of the trip data as we proceed in this presentation, but I want to give a few other shout-outs for some uses. We've had this on the market for a few years now as trips. Again, we've just introduced it in the coalition as an official ancillary product. But I want to give you some examples of some things to point to. Minnesota DOT and SRF were one of the first users of this data. They licensed some data to support a major investment corridor study along I-94 in the Twin Cities area. There's a couple of links to both the study and SRF information about how they used it. As part of that, Paul Morris and the team at SRF actually exercised, they kind of did, what can we do with this data now that we have it? There's a link here in this presentation, again, a couple of years old, but the same data and the same ideas, and you can see it's one of the best summaries of, if you know how to use GIS, if you're not afraid of the size and volume of the data, what you can do with this data. SkyComp, many of you may have used them for their aerial TLAP studies. SkyComp takes this data and either independently or along with those studies can create what we call high-resolution origin destination studies. There are some links here. They've done this now over a dozen studies in 9 states, leveraging this data. One of the things that is not going to be mentioned in the next few minutes related to University of Maryland work is along with the coalition, UMD is kind of nearing the end of a research project related to volume and turning movements. There is a great summary presentation, the link is here, about how they've leveraged this trip data in various states with some other data coming together to create volume estimates, essentially volume archives, ADTs, and et cetera. Something we're very excited about and looking to build on for the future. Finally, last one, there's been a lot of work, a lot of talk and research. Purdue and the folks, Dr. Steve Remius, who is a Purdue alum, is building a nice little presence in Michigan and Wayne State. He has the most recent presentation, again, in depth with trajectory data with high-frequency waypoints. What can you do to support and improve signal performance assessment and measurement? So anybody that's looking in that area, I urge you to go to that presentation and start. So in summary, I'll summarize again. This is an enabling data set that's here to help. It is directly measured. Everything I share there, none of that is imputed. Data now pressing 5 years of historical data. It's available across the United States with lots of uses demonstrated, but lots of innovation still possible. It's available for licensing under the VPP at the best possible fee with the VPP's liberal use terms. And there's plenty of ecosystem partners that are available to leverage and utilize this data. So we're very excited about it and look forward to working with everybody to prove out and continue to advance the state of the art and what can be done with this data. With that, I'll turn it over.
Thanks, Rick. Thanks, Rick. Everybody, just so you know, the questions that are being put in the chat box right now, as they're being answered at the end, when you get a link to these presentations, we will also have a documented summary of these Q&As. So hopefully, Rick, you want to take a look. There's been quite a few stuff, quite a bit of information coming back and forth in the chat box. Please feel free to enter as we move to the next presenter, but I see some good questions there. Okay?
Great, thanks. And Jim Williams and Jose are on INRIX staff too, so they're answering the context with people. Cheers.
Great, okay.
Thank you.
Super. Thank you, great. Good job. Next we have Dr. Ghader. Can you hear me?
Hello, yes, can you hear me?
Yeah, all righty, yes we can. Take it away, sir.
Okay, good morning everyone. So today I'm going to talk about a federal highway project related to the OD that we are doing as a part of Exploratory Advanced Research Program at Federal Highway. In this project, we are exploring the ways of producing origin-destination matrices from various mobile device data sources. In this slide, you can see our project team. So University of Maryland is the lead. Dr. Lejean is the project PI, and I'm the project manager. We also work at the university. We also work with National Transportation Center at University of Maryland and also Center for Geospatial Information Sciences. I also want to acknowledge the help of CATT Lab here. They also helped us a lot in this project for our visualizations. And we have our state and MPO agency partners, our Baltimore Metropolitan Council and Maryland State Highway Administration. And our data providers in this project are AirSedge and INRIX. We also work with Streetlight through INRIX. The objectives of the project are first to explore the potential of producing person OD tables from different data sources, mobile data sources, such as cell phone, GPS, and location-based services. And I describe a little bit on these data sources in the next slide. And we also want to have this OD data at different levels, such as the national level and MPO levels. And we also want to explore the potential of segregating these OD tables by travel mode, trip purpose, time period, and socioeconomics and demographics. We also want to explore the potential of generating truck OD segregated by time period and vehicle class. And also, we want to help the users of these OD data and other data coming from the mobile data to better understand the mobile data, because it has been kind of a black box, and we want to make it more clear for the users to appreciate the data more. So I talked about different sources of the mobile data. Our first source is GPS, and as you know, GPS can be in vehicle or it can be on the phone. Our second data source is cell phone, which is in some literature known as CDR data. It's data coming from cell phone towers whenever the user call, text, or in any way connect with the cell phone towers, the location is saved. And our third data source is location-based services known as LBS, which comes from any apps in the mobile phones that get the location of the users. So mainly we work with three data sources to produce the OD tables. And we have some research products here that we hope to deliver to the community. First one is a data sandbox, which is a sample of the raw location data, somehow processed and randomized for privacy concerns. And we share these input data, these raw location data with the community so that they better understand the mobile device data and improve their confidence and appreciation of the data products relevant to the mobile device data. We also try to develop open source algorithms for a couple of imputations and identifications, such as trip end identification, imputation of trip purpose, travel mode, and social demographics. And also we try to develop open source algorithms for extrapolating the sample of data and correcting the sample biases. We also try to validate the end product, the OD, so that people can see how these OD products that are being produced from various data sources can be validated against the external data sources. Besides, we also developed a national personal microsimulation travel demand model, and we calibrate these demand model using these new data sources so that it can be used for scenario analysis and predicting the future demand. Besides this research product, the main product of this project is going to be OD tables. We have OD tables at two different levels. The first level is the national level, which has MSA to MSA trips. And as an example, we worked with Baltimore Metropolitan Council, and we got their TAZ structure, and we produce the OD from these various data sources at the MPO level, just to showcase the capability of producing these OD table at zone structures of MPO. It can also be done at state level or different levels. So here in the slide, you can see our national OD product. We are producing it from 3 different data sources: cell phone from AirSedge, GPS from INRIX, and LBS from Streetlight. And our study area is 400 MSA zones, and we divide the rest of the state. Each state that is not a part of any MSA, we consider that as one non-MSA zone. Our study period is year 2017. We have our products separated by average weekday, average weekend, and final OD tables will be separated by social demographic groups, by trip purpose, by travel mode, and by month of year. And just to define what should be included in the national OD products, we define all trips longer than 50 miles as long distance trips, and these are the trips included in our national OD product. And our sample state MPO level OD product is related to Baltimore Metropolitan Council. And again, we are producing this data from 3 different sources: cell phone from AirSedge, GPS from INRIX, and LBS from Streetlight. And our study area is around 3,000 zones covering the Baltimore metropolitan area. Study period is again 2017. We have the products separated by time of day. We have 4 time of days here. Again, the data is separated by average weekday and average weekend. And all the final OD products would be separated by social demographic groups, trip purpose, travel mode, and month of year. So we try to develop algorithms and share some level of raw data with the users. We also try to validate the end product using various data sources that are out there that can be used for this validation. This is just a list of data products that are out there that can be used to validate the product, the end product. Some of them, for instance, are airline OD surveys, DB1V, that can be used to validate the air mode tables. We also have traffic counts that can be used to as a source of validation. Freight analysis framework data can be used to validate the freight part of the data. And there are certainly other data sources that can also be used, but this is just a list of examples. But besides validating the end products that is important, it's also important to validate all the algorithms that are working behind the scenes to produce these end products. Algorithms such as sample expansion algorithms, mode, purpose, and social demographic imputation algorithms. And for these, we are collecting some macro-level ground truth data that can be used to validate all these algorithms. And I briefly want to mention two other federal highway projects that we are doing at University of Maryland. But first, let me talk about the schedule and the status of this current project. This is a 3-year project started at November 2017. So we just finished the first year of the product, and we delivered the first year OD product to the federal highway. And we are validating and visualizing the OD product, and we are working on the sample expansion and imputation algorithms. And the data sandbox that I mentioned, we are producing a sample of this data, hoping to share it with the community, and we are hoping to announce this sandbox at TRB this year. The two additional projects that I briefly want to mention, that we are again doing them for Federal Highway here at Maryland Transportation Institute. In one of them, we are tracking mostly multimodal travel trends using only public domain data. And the other one is estimating VMT, mainly at local roads, from GPS vehicle trajectory data. Both of these projects are for Federal Highway, and they produce products available for state DOTs and MPOs. This is just an example on the monthly multimodal travel trend project. Here you can see the mode share at different months by different modes. Here we have driving for hire, non-motorized, and transit. And just as an example for the VMT estimation project, you can see that this is the VMT at different functional classes for different months. So, just let me mention that by TNC, I mean Uber, Lyft, and other ride-sharing products. So I think that's it. For any more information, you can contact Dr. Lejean, or you can contact me, and I'll be happy to answer if there is any question in the chat box.
Sepehr, thank you very much. That was great. Yes, keep monitoring the chat box. It's been a very lively box we've got going on here.
Sure.
I believe our next, thank you very much. It was good. Next presenter, Dr. Mark Franz. Mark, can you hear me?
Yeah, I can hear you. Can you hear me?
We can, yes. I think you're up next. Are you going to take control, I believe?
Yeah, I'll share my my screen here.
Okay. All righty, take it away. Thank you.
Can you guys just confirm that you can see my screen?
Yes, I can see
Okay,
it.
great. So I'll be presenting today on some of the products that are have been developed or are in development by the CATT Lab that's ingesting this OD and trajectory data that we've been talking about today. So the background of trajectory data, I think that we all understand what that is now, but just briefly reiterate what the other presenters have described. It's essentially timestamp location data from GPS and cell phone devices from various third-party providers like INRIX and HERE, and there are others out there. And the data is collected on the individual trip basis. And by trip, I mean that it's a sequence of timestamped waypoints. So it's essentially a lat and longitude with a waypoint with a timestamp so that we know the sequence of the trip, and we can reconstruct those waypoints and figure out what the route taken was for a given trip. So the other information we can pull from it, as you guys are aware now, is the departure time and location time, the route selection that they have, the travel time for the entire trip rather than looking at individual segments at a time, which is what traditionally has been done with probe data. and also the arrival time and the location. So we can do things like OD matrices and a few other types of applications, which I'll talk about in my presentation. So some applications that we identified when we first got our hands on this data a little over a year ago was to first try to see what applications this could be used for in terms of supplementing existing methodologies or maybe coming up with some new functionalities from this emerging technology. So things like OD patterns, trip travel time we've heard about, get multimodal information. You can also look at very specific use cases such as understanding work zone impacts and detouring related to that or traffic incident management. You can use this to drive policy changes and all those types of applications, but I'll illustrate that with some use cases as we move forward here. So some initial visualizations that we did with this data is to show sort of what travel patterns look like. Shown here is one typical day in DC. So it's a time-stamped movie, and you can see the individual vehicles represented by various dots with their speeds represented by green, yellow, and red, depending on their speed. So we can use this to better understand, what travel patterns are, at a very microscopic level, to see how that's impacting the performance of the network itself. But before we can get to really, doing those types of visualizations or using this data to extract actual useful information from it, there's some challenges with it, as we've heard about. So first of all, it's a very big data set. So our sample data that we got was from 2015. It was one of the first iterations of the trajectory data that we got. It was just 4 months of data, and it included any trip that had at least one waypoint within the state boundary of Maryland. So that was over 20 million trips just for those 4 months of data. With those trips came 1.4 billion waypoints, and the original size of this data was 112 gigabytes. So some other challenges that had to be overcome with this initial data set was what's called snapping. So you can still get the data in this format if you prefer, the raw lat and longitudes with a timestamp. But as Rick mentioned in his presentation, sometimes there's not perfect resolution and accuracy in the GPS data, so you have to figure out where that raw lat and longitude falls on the roadway map. Since we got this original data set, though, I know that INRIX and other data providers are now pre-snapping this data to the TMC map. So if that's the map that you're commonly using for your analysis, like we do at CATT Lab, you can get the data in that format. The other challenges, and again, this refers to something that Rick talked about, is the temporal resolution of the data. So sometimes these waypoints could be collected every few seconds, and in some cases, though, it could be a few minutes. So depending on where that trip is taking place, whether it be an interstate or a central business district area, if there's a couple minutes in between the waypoints, there might be several different routes that could be taken to get between those waypoints. So we have an algorithm that we pre-process that data to take sort of our best guess at what route was taken in between those waypoints, so you can do more advanced applications with it. So what I'll do now is walk through a few use cases using our tool that we have developed. The first one is to develop just a traditional OD matrix where the origins and the destinations are the same. So an application might be, let's say, and again, the data that we have is from the state of Maryland, so let's say the state wanted to investigate any equity issues with maybe implementing a vehicle miles traveled tax and wanted to see what the travel pattern at the county level was. So I have a screen recording, which I'll go ahead and play. So I go in and I select my data set, and state of Maryland, I'll go to the OD tool. As I mentioned, I'll do the traditional development of the OD matrix. And as I mentioned, I'll select at the county level is what I want. So it gives me a preview of what the matrix will look like. If I'm okay with it, I can go ahead and generate the matrix, and then it'll query the database and fill in the matrix with the trip data. We can filter by time of day, day of the week, or month of the year. I'll leave all of them on in this case. I'll change them in other applications. We have trip filters, vehicle type, light, medium, heavy. and also different ways of defining how we count the trips, whether it's arriving, departing, or en route, based on our cutoff time period. We can also switch from total counts, or total trips, I should say, to percentages. And everything that we have is dynamic, so you can go ahead and play around with the filters and the thresholds for coloring the matrix based on what you want to highlight in the map itself. When we do the symmetrical matrix, we can also do what's called a chord chart. So this can link that matrix to another type of visualization. Let me go back on that. So what this visualization does, it takes those top 10 OD pairs and puts them in another interface that's dynamic, so you can hover over them and see where, in this case, the percentage of the total trips in the matrix are starting from and going to. Also, by hovering over any of the locations on the map, you can highlight the OD pairs that are shown in that chord chart. And with the relative size of the chord chart showing more trips, as you might expect, a lot of at the county level, there's more internal trips than anything else. But you can use this to identify and produce visualizations to further enhance the OD matrix analysis. So sort of related to that, we can develop what's called a custom OD matrix. So in this particular application, the origins and destinations are not the same. And so a use case here might be, let's say the city of Baltimore wants to investigate where trips are coming from to a particular area in their city where they have a parking management problem. So they want to look at commuting trips from the surrounding counties into traffic analysis zones within their city. So as before, I'll go ahead and select the Maryland data set. I'm still going to use the OD matrix tool, but this time I'm going to select custom axis so I can define different origins and destinations. It won't be symmetrical. So for this application, I'll select a few counties that are surrounding the city of Baltimore. So that would be Baltimore County, Anne Arundel County, and Howard County. And then for my destinations, we can select at the traffic analysis zone level whichever ones we're interested in. So in this hypothetical example, I'll select the first 4 traffic analysis zones. Again, I get the preview of my matrix, and if I'm satisfied, I can go ahead and select Generate Matrix, which will then crunch the numbers and give me an output similar to before. Now I can apply my filters if I'm going to look at the AM peak period from 6 to 9 a.m. Just during the weekdays, I can turn on those filters dynamically. It'll update the map when I click outside of that box. Again, this is more of a parking management use case, so I'm only going to look at the light vehicles, the commuting people. So I can do that, and again, it'll update the map. And as before, we still have the other matrix controls where we can switch between the percent of trips that we observed in our data set or the raw number of trips that were in that database for after we apply those filters. So that will just update, and you can use that output in a similar fashion. So the next use case that I want to show is what's creating what we call a pass-through matrix. So you can select a geography or a segment of interest to find out where those trips originated from and where they're terminating at. So you can use this for policy type, driving policy type changes. So let's say, for instance, in this use case, we select a regularly highly congested corridor in Maryland, the I-270 corridor where it meets the Capital Beltway, and we want to figure out where those trips are starting from and ending so that the employers where those trips end can maybe be incentivized to let their employees have telework or flex work schedules to help alleviate some of the peak period congestion on that road. So again, data selection, I'm still using the state of Maryland. Now I'm going to use what we call the segment analysis tool to develop this pass-through matrix. Similar to our other tools in the Redis platform, you can do the text selection, also point and click. In this case, I'm using the text selection. I'll look at the southbound direction of I-270. So again, this is going to be focusing on the AM commute on this particular corridor that's regularly congested. So I can go ahead and select that segment that I'm interested in. And again, I can look at different various geographic resolutions. For this application, I'll look at traffic analysis zones, but it could just as easily be counties or sub-counties. So the output we used is we used the color of orange to show the relative number of trip origins that used this road segment that's highlighted in green. So this is just summarizing where these trips started from and where the higher density trip origins were for that particular road segment and time filter that we applied. We can also switch to destinations, which we use various colors of blue to show. So we can see at the TAZ level where those trips are terminating at. So again, we can use this to better inform our policy decisions. We can turn on data labels, things like that if you want to get more specific information. So that's sort of the pass-through matrix tool that we have. So one tool that we're working on and are getting very close to deploying is to analyze specific routes that are taken. So we have some initial mock-ups here of what that would look like in the tool itself. We'll have an interface that looks like this, where you can essentially go in and draw an origin and destination of interest, or you can select a predefined geography, such as a county or a TAZ, whatever the case might be. And anytime that you draw a custom geography, as with the rest of our tools, you can save that geography so that you can pull it up at a later time if you want to do a different type of analysis. So, and then the next step then is to look at what the output is. So after you define the origin and destination of interest, it'll go ahead and crunch the numbers and give an output of a map showing the routes that were taken between that OD pair, with the size of the swap width of the given route showing the relative number of trips versus the other one. So we see the green and the purple and gray being shown here. We supplement that relative volume or trip data with the travel time information for various times of the day, so we can better understand how much time is being spent for people traveling between those OD pairs on a given route. We also have some other tools that are in the works looking at observed travel times for any point of interest to create travel time contours. So you can see here, you can do this for a lot of different applications. One might be to assess emergency evacuation, to identify if there's any one choke point in a given direction for people getting out of a danger area that might be identified. So we have data now that we can observe to create these travel time contours to better inform our planning for evacuation. We also, as Sepehr mentioned, one of the products we helped the Maryland Transportation Institute and Sepehr's team was to visualize some of this national OD data. So we have a tool that looks at this at the MSA level. We can dynamically search for various MSAs. Again, we use orange and blue for coloring the origins and destinations respectively. We can also control how many of these top-ranked pairs that we see on the map, and supplemented with the bar chart on the side showing where these trips went from, in this case, from Los Angeles to various other MSAs in the United States. And as Sepehr mentioned, this data is based on cell phone information, so it is multimodal. We obviously have airplane trips that show trips crossing the country, so we can make some inferences about what types of modes are being used between origins and destinations from that data set. And then finally, in a related project that we did for the Baltimore Metro Council was to ingest their planning model data. And so because this is planning model data, we're able to collect the information on every single vehicle in the simulation model. And we know specific information about the model trips, things like the vehicle occupancy, if it's SOV or HOV. We know the trip purpose, if it's mandatory, non-mandatory, value, time, and household income. So we can filter by those various factors in the planning model data to use that to evaluate any equity issues that might be happening from proposed development in the planning model. We're also working on ingesting transit data. So shown here is some ingested data from the Maryland Transit Authority. So we're looking at various routes where people are using to transfer to other routes on buses. Of course, this requires that you have both swipe on and swipe off data to do the boarding and alightment data so that you know what the true origin and destination is. So that's a product that's in the works. And we can also do this for rail. Obviously, here in Washington, D.C., there's an on and off swipe. It's for the fares. It's not a flat-based one, so we know the origins and destinations of various trips from the WMATA transit system here in D.C. So we're working on developing some additional visualizations to show the OD patterns on light rail for Washington, D.C. But we can do this for essentially any data set that's available. So I'll go ahead and conclude there and pass it on to the next presenter.
Thank you, Mark. That's going to be Michael.
Okay.
He's rounding out the group. Michael,
and I'll be happy, of course, to answer the questions on the chat box as Michael presents. So thank you.
You're welcome. Thank you. Yes, we've got a lot of good questions in the chat box. And as I mentioned, we will be providing those along with a link to these presentations once we're done. All righty. Michael, go ahead. Can you hear me?
I can hear you. Can you hear me?
Yes. Go for it.
All right. So I'm going to be talking about some potential applications of using this waypoint and trajectory data for signal timing analysis. Now, I don't want people to get confused because the CATT Lab already has some tools that we're developing with PennDOT and Purdue to do signal analysis. But these tools make use of the INRIX XD data, that's your probe data but at a finer granularity, to do CDF plots and look at the change in signal timing plans over time to see whether or not you're increasing reliability, decreasing travel time, or some mix of that. That is not what we're talking about today. Those are features that can be used with the XD data, again, through PennDOT and Purdue. Today we're going to be talking about how to do something different using the trajectory data. So what we'd really like to see as signal folks is not the travel time from one intersection to another intersection. Instead, we'd like to see what the travel time is getting through the intersection. So from one mid-block point to another mid-block point. And that's been, very difficult to do for forever. But now that we have this waypoint data, if you overlay enough waypoints onto a map like this, you can start to actually see people moving throughout a network, taking different routes, making different turns, and you can calculate the actual observed travel times getting through these intersections. So now imagine being able to go in and actually see that. It takes 42 seconds to go here, then 55 seconds to get there, and so on and so forth. Being able to apply the same type of filters that we saw earlier that Mark just presented for looking at travel times during certain date ranges, during certain times of day, days of week, and then figuring out how long it's going to take them to move through intersections at different points on the map. So the CATT Lab is now taking an even deeper dive look at this data set and trying to figure out what other cool things can we do for signal performance measures. So imagine being able to go in to a state, selecting a particular county within a state or a zip code, or maybe a specific intersection if you want. But let's look at a larger area and look at some sort of date range, and then the tools go out and they grab all of the different intersections, signalized intersections within that particular region that you just selected, and it gives you some basic information about the average travel times to get through the intersections, and then some little graphical displays that give you some sort of sense of, is it taking longer to go north versus turning left versus turning right, and so on and so forth at the different approaches to these intersections. or being able to click on an individual intersection, do a little diagram of said intersection, and then give you some sense of the average travel times throughout the day to turn left versus turn right, go straight from a different approach here at this location. The neatest thing, though, that we're working on is being able to go in and actually do a ranking of all of the turning movements within some region. So if you're familiar with our bottleneck ranking tool that we do with regular probe data, this is kind of like the bottleneck ranking tool, but it's an intersection turning movement ranking tool, where we go in and we look at every single approach for every single intersection, and we tell you that if you're at 8th Avenue at West 23rd Street and you're approaching northbound and you're about to turn left, here's what the user delay cost is, here's what the average travel time is to get through the intersection, plus the 25th, 75th, 5th, and 95th percentiles. And then being able to actually look at how many people get through that intersection in 1 minute versus 1.5 minutes versus 2.5 minutes versus 3 minutes versus 5 minutes. And what's particularly exciting about this data is that it starts to turn into the poor man's or maybe the smart man's ATSPM. So instead of having to have detection out at every single intersection, you're actually able to use this data to pick up on the signal phases at the intersections and see who's getting through when. Then you can move in and you could click on a different approach, and it would then jump you over to that particular approach and give you the stats for that approach as well. And then we're working on another project at the University of Maryland for estimating volume and turning movements. So we can then overlay the volume and turning movement data on top of these tools to give you those volumes, those counts. Or if you have actual detection at the intersection and you can provide that to us, then we can overlay those volumes as well and give you the ability to interact with your intersections and see who's going through and how long it's taking them on average. So blending these different data types together. And then lastly, we're also looking at just travel time sheds. Mark showed you this a little bit earlier, but let's say you want to originate a trip at a particular intersection or a particular location in the city. How far can you get in 1 to 2 minutes of travel versus 2 to 3 minutes of travel versus 5 to 6, 4 to 5 minutes of travel? Being able to diagram that on a map as a planning tool. So everything I just showed you is in progress right now. We're still developing it. It's not ready for prime time yet. We're hoping to test with a few agencies in the next few months. We're still experimenting with the density of data that's needed to make everything statistically significant and work out just right. And we've also begun some working groups where we're getting together potential users from different agencies to come and talk to us and tell us what types of functionality they'd like to see in these tools that we haven't thought about yet, or tell us which functionality isn't needed. And that's all I've got. Now I'll dive down and start looking at the chat box and see what questions have come in. Thank you all for listening.
Michael, thank you. That was great. There are some questions in the chat box, and if you'd like to add your input into them, that would be great. Joanna, could you go to the next slide, please? So, I guess before we get started or see if there's any questions beyond what's in the chat box, I did want to make everyone aware that Michael is putting together a origin and destination working group. We provided this information to those that were on the user group meeting last month, but he is in the process of developing a steering committee and a working group for OD. So if you or anyone that you know might be interested in working on that, if you would like to email Michael or myself. about that, we would be glad to add you to the list.
For one of us.
Okay.
Yeah. He's back. I'm sure it's going to be open.
I'm hearing some background. I'm hearing some background. Somebody needs to be on mute.
I guess send us both an invitation. If you're going to send an invitation, we'll decide who goes. Does that work?
There we go. Thank you. All right. So, with that being said, Michael, do you want to walk through any of these questions in the chat box right now? We have a little bit of time left, or do you want to just simply have the folks continue to put some questions in the chat box and you answer them that way?
Let's have the questions keep coming in through the chat box, and I'll type them as they come in.
Okay. One of the things that we are going to do is, and it's a little different than some of our other user group meetings, is that we are going to leave the chat line open for 5 or 10 minutes after the presentation is done. That way, if any of you still have some questions that you wanted to ask, thought about it and then decided no, and then all of a sudden want to ask it, you've got time afterwards now to be able to put that in the box, and then we will have our presenters answer them and include them on the Q&A. So even though we might be signing off in a couple minutes, please, if there's anything else you want to add, please keep typing it in the box, and our presenters will answer that and send it to you. Okay. So also on the slide, you'll see that the meeting information, the presentations are going to be posted on our website. You will get a link. For those of you that might be registered in this participant box and you have your name, you don't see your name, or you're listed as a 1, 2, and 3, and you want to direct the link, please again send the email to Joanna or myself so that we can make sure that we get you on that list. Okay. I think with that being said, Joanna, is there anything else that I missed? I want to thank our presenters. You guys were all great. Great information, new and exciting stuff. Joanna, anything else?
No, Denise, I think you covered everything.
I think we got it. Okay. So with that being said, I'm going to sign off, but please know that you can continue to enter into the chat box if you like. All righty? Okay. Have a nice day, and happy holidays to everyone.